to the negative 2th power, we can actually bring this together, y times x to the negative squared, negative 2th. Good morning, fellow mathematicians! Welcome back to another video. Once again, exercise time for inexact differential equations, mate. And we are going to dive right in. Like I said in the previous video, it's a matter of sheer luck if you can actually find out an integrating factor. And if you go through the ways of using a single variable integrating factor, for example h of x or h of y, you are probably going to find some antiderivative, which is somewhere in the exponent. But sometimes it does make sense to check for the other ones. And this time we are going to try out if h of x times y is going to work out. It's going to work out. I wouldn't do it if it wouldn't work out. Okay, so at first thing, you see this differential equation is nice and symmetric in x and y. We're going to see if this is actually exact or inexact. It's inexact. So let us see what del y p is going to be. Well, this is going to give us 3 times y squared plus x times y with a 2 in front plus 1. But is this thing equal to, well, del xq? I don't think so, because del xq is nothing but, okay, this is going to give us 3 times x squared. Okay, it doesn't work out, so you can already see. So this thing is not exact. I hope you can see that this is not equal at the moment. Okay, doesn't work out right here. This is the reason why we have to take a look at integrating factors. I wanted to pronounce it right now in this integral thing. Integrating factor. It's an integrating factor, okay? Integrating. We're going to take a look at m of u. Okay, it might seem counterintuitive why we should use this right now. It's just a matter of try and error, okay? So I was thinking of those exercises on my own, and this was the only one that worked out pretty nicely. So the other ones do work out too, but it's an absolute mess, okay? Because right here you're going to get something over 3rd degree polynomial in y or x, and that's not cool to factor. So this thing right here works out way better. Now let us calculate m of u. Okay, u in this case means x times y, and then we're going to see how this turns out. Okay, m of u is thus nothing but del yp. We know what this is. This is nothing but 3y squared plus 2 times xy plus 1 minus del xq. It's nice and symmetric, like I said, so we are going to get 3x squared and then plus 2 times xy, but with a negative sign, because we're going to take all of those parts in del xq as negative, and then negative 1. You might notice, curiously, that this and that and this is going to cancel out. Also, we can factor out the 3, and then we have y squared minus x squared. But this is for another time. Okay, give me a second. Y times q. What is y times q? Y times q is exactly y x to the 3rd power plus y squared x squared plus y times x minus x times p. So minus x times y to the 3rd power. Oh, this is so nicely. I can already see it. I haven't done those in ages, so this is kind of improvised, but this turns out really nicely. Oh, this is such a cool exercise. Really nicely. Plus, no, negative x squared y squared minus x times y. You see, this and that and this and that is going to cancel out, leaving us overall with, like I said, a 3 in the front. Y squared minus x squared over y times x to the 3rd power minus x times y to the 3rd power. Ooh, this is absolute golden, okay? So both of those have a factor of x times y, okay? This is so nice. This is such a nice thing. Y squared minus x squared over, okay, like I said, a factor of x times y. But what do we have left after factoring that out? Well, right here we are going to have x squared, and here we are going to have minus y squared. Meaning, if we factor out a negative sign, this and that is actually going to cancel out, giving us overall an m with a value of negative 3 times 1 over x times y, but we wanted to assume that x times y is going to be our integrating variable up here, our u in this case. Ooh, this is really spicy in my opinion. This is really cool. Meaning, our h of x times y is thus nothing but x of an integral. Now we are going to get -3. I'm going to put it to the front. Du over u is snack. Now, this is going to give us the natural log of u in this case, so natural log of x times y. X of natural log of x times y in this case, we can bring -3 in, so this is going to give us the natural log of x times y to the -3rd power times e snack. Now, exponential function of the logarithm, the natural logarithm, is just going to be the thing in itself, meaning our integrating factor is nothing but x times y to the -3rd power e snack. Really good sheet, really good sheet. This worked out so nicely. This right here is a nice and compact, compact in the sense that it's really small, okay, not analytically compact whatsoever. Small integrating factor. Now, all that's really left to do is to check if, when multiplying our h with p and q, if the partial derivatives are going to be equal after that, okay? So let us take a look at del y h times p. That's going to require a little bit of thinking. Now, e snack is going to cancel out on both sides once again, just like the last time. It's just how it works out. It's not equal to 0, we can cancel it out. Now, y to the 3rd power and 1 over y to the 3rd power is going to cancel out. So x to the, that's going to be del y then, x to the -3rd power. Then we are going to get plus, okay, x to the, I'm going to put it like this, x to the -2th power, and then y to the -1th power. Like I said, this is going to require a little bit of thinking, plus x to the -3rd power, plus y to the times y to the -2th power. Now differentiating this with respect to y is going to give us, this is going to cancel out in the process. This is going to give us negative y to the -2th power. We can actually bring this together, y times x to the -2, -2th. Now if you differentiate that, it's -2 times x times y to the -3rd power. Okay, this has been the first part. Now del x of h times q is going to be nice and symmetric once again, so that's del x of, let me still think, so y to the -3rd power. And then we are going to get plus x to the -1th power, y to the -2th power, plus y to the -3rd power, x to the -2. Okay, if we differentiate with respect to x, this is actually going to cancel out. And then we are going to get, dragging the negative down, negative x times y, -2, and dragging the -2 down, -2 x times y to the -3rd power. Hey, who would have guessed that this thing right here is actually our integrating factor? This actually required me to think a little bit, but yeah, we have made this differential equation exact. And it worked out quite nicely. And yeah, after this exercise, we are going to deal with the case h of x over y or y over x whatsoever, and we are going to see if it turns out quite nicely. I hope you did enjoy this video. If you did, please like and subscribe and recommend our channel if you like. If you want to support our channel a bit more, buy those t-shirts I created, because I want to get even more Hagoromo chike, but I'm a poor bitch and I don't have any money. Hagoromo, I want you, I need you, my boy. And yeah, share those videos everywhere if you did enjoy them. Until the next video, have a flammable day. Ciao.
Ich sauge zu Hause, ja. Aber keine Allergie. Nee, ich habe Eingequote. Mit Beutel. Und beim Wechseln